welcome to the talk, Automating Victory, Beating Browser Games with Accessible Python. Without further ado, let's get started. Despite some confusion, I am Jon Gaul. Tom Gaul is my cousin and also uncle. I grew up in North Dakota, went to school at Georgia Tech in Atlanta before moving to Japan to become a software engineer at Henge. Check out our booth. We're really cool and also hiring. Some less technical interests. I love bouldering, wrote a kid's book, and have a soft spot for video essays on YouTube. Last year, though, I spent some quality time writing a Python script to automatically beat a favorite video game of mine, and I've punched it up into a talk. I'd like to discuss some project management tips I learned along the way, give you the update on some useful I/O libraries, and, of course, talk about a cool video game. Does anyone in the audience like video games? Oh, wow, a lot of you. So this is going to be disappointing. The whole talk is about not playing the video game, about getting a script to do it instead. But don't worry, we'll introduce a cool one in the meantime. The game itself is called Momono Sweeper, originally released by Japanese game dev Hojimaka Games all the way back in 2010 as a Flash game. It got a re-release in 2015 as an HTML5 or as an Android game, and finally an HTML5 port that you can still play to this day. The game itself is a cross between Minesweeper and an RPG, but instead of mines, you have to watch for monsters. Let's meet them. Instead of Minesweeper, where clicking on a monster is the end of the game, here you can click any unrevealed monster at or below your level to beat it. It'll reveal the tile, get some experience, and eventually level up, so you can click higher level monsters. Of course, if you click on a monster that's too high level for you, you'll lose some hit points and eventually the game. If you click on every monster, you win. Hooray. Like Minesweeper, the number in the empty tile gives a clue as to the surrounding neighbors. But unlike Minesweeper, the number is the sum of the levels of the monsters around the tile. So here, for example, the number's 3 because there's one level 1 neighbor and one level 2 neighbor. Of course, there's other options. And those other options are where this game actually gets difficult. If you see a 3 surrounded by unrevealed tiles, in vanilla Minesweeper, there's 56 possibilities. But in Momono Sweeper, there's 120. You can check my math down below, whether it's all level 1s, a level 1 and a level 2, or a single level 3. So in that sense, the game's a lot harder than Minesweeper. But in another, it's much easier. Because if you're level 3, the correct move is to click all of the surrounding tiles. You'll reveal them, kill the monsters, gain some experience, and reduce that overall uncertainty that adds to the difficulty. With that in mind, difficulty levels come down to how many monsters there are, how densely packed they are in the board, and how many you need to click to level up. Difficulties range from easy to huge and extreme, where the dev has described that as yaranai hoga ii, or you're better off not playing. And this game is really fun. I played it on the plane over here. I will play it on the plane back to Tokyo. Beat it on every difficulty level, no damage, then bricked my phone and did it again, except for that last difficulty. The problem with that last difficulty is you have to click all of the empty tiles. You don't get to level up. You don't get to gradually reveal more and more of the board. It's very luck dependent, and even in there, the strategies are so math dependent that it's easy to make an addition mistake and lose a game a couple hours in, as I have done often. So that repeated addition for a long period of time is difficult, but you know who doesn't have problems doing a lot of addition for a long period of time? Python, of course. And so I had this cool idea where I can automate these strategies. The roadmap would look a little something like this. Basically what I do, only better. I would look at the board, parse that into some sort of numerical model. I would do all those strategies, but with the help of Python doing the numbers for me. And then I just click and repeat. So with that in mind, I ignored the project for 3 years, which is fairly common, I think, for personal projects, where there's some cool idea you have in mind, in this case, automatically executing tricky strategies, and then the fluff work to make that happen kind of gets in the way. But I found a solution for me, at least, and I wanted to share it with you. So you start with a challenging plan, and you fix it by taking away everything but the first step. In more fancy lingo, this might be to make your minimum viable product very minimum. In my particular case, that started with just asking the question, could a Python script find the game window? And with two libraries, MSS and OpenCV, the answer is yes. MSS takes screenshots very quickly, and OpenCV is the go-to open source image processing library. We are barely scratching the surface on it, really only using the match template function, where you take a sub-image and find its position in a larger image, which in this case is the screenshots. With these very simple tools in mind, I was able to get results after an hour of tinkering. They weren't great, but they worked as a start. Of course, dealing with an array of pixel values isn't what we want. We want numbers, things we can work with. But again, smaller steps will mean that I can actually get this project done. Here, we're going to need to know the level anyway. It's always in the same place, and it can only be 1 through 9. So let's just check it out. And of course, we want our solution to generalize, and optical character recognition is a well-studied field. We're not going to use that because it's also a very complex field with a lot of work on it, and there's 35 pixels to match. We're just going to compare the numbers we see with some references. And of course, as the project goes along and gets more complex, we can revisit it, which we immediately have to do because it complains if it encounters an empty space, a filled space, a space with a monster. And of course, this involves going back and revisiting things. But I can do so off of working code. It's much easier to start with a function and modify it to do what you want, rather than get it perfect from the start. And eventually, after more tinkering, I got a working numerical model, so I can finally consider those strategies. And the reason I started this project, what's that simplest strategy? That's right, click randomly. You're gonna need to do it anyway, and you might as well start with that. The fun stuff can come later, but don't worry about it. But of course, we have a square we want to click. How do we click? You might actually know about this one. There's a great library called PyAutoGUI that allows a Python script to send arbitrary mouse and keyboard inputs. It's a great solution for strange problems that would like to have an API but don't have one, or would like to use file manipulation but can't for some reason. It's easy to customize, and there is no better tutorial than Al Swiegert's book, Automate the Boring Stuff with Python. And so, that's the list. We have working or moderately working steps for all of the things that kept me from starting. And even though live demos are a terrible idea, I do have to show you what this looks like in context. So this is just randomly guessing, and let's see if it works. Oh, come on. Oh, you were just working, my friend. Oh, strange. What? Where are you? Oh, this is all going to pot, but that's fine. Oh, live demo curse. But terribly embarrassing. It is code. What can you do? Oh, God. Oh, it does not like me today. Oh, it doesn't know which screen I'm on. Okay. Well, that's too bad. Unfortunately, I have to go for my safety video. So, and here's what it would look like if it could run. Full screen it at least. Where it just kind of guesses randomly, struggles for a while. It succeeds at failing very quickly, but succeeding at failing is not exactly what I would like it to do. Oh. I'm greedy. I want to try one more time just to see if I can test it. Make it run live. Nope. That's okay. We can go for safety videos on this one. So, as I was mentioning earlier, present review. In a sense, this MVP is not particularly impressive. It's succeeding as a statistical error. But going through with that mindset is a killer for personal projects. It's much better to view this as a small series of successes that builds into something that might be cooler. And getting here took a lot of small successes. So now that we can get to the point where we can click something, we should probably look at that simplest strategy again. Once again, but actually this time, if a square's number is equal or lower than the current level, its neighbors are all guaranteed to be safe. So here, the red box numbers must be less than or equal to 1. And pseudocode might look like this. It's totally fine. For each row, you check each column, and for each grid location, you see if it's less than or equal to the level you're currently at. Then for every neighbor, you add it to some set that's safe to click. And that'll function. But as a seasoned Python programmer, seeing all those nested for loops gives me a little bit of discomfort. As an interpreted language, it really struggles, especially as you get to a larger grid size. But since it'll work, why waste time trying to optimize the function? Well, in short, because I care about this part. It's the reason I started with this whole project anyway. And of course, doing these optimizations means that later on, as we encounter harder strategies, we can learn techniques that'll help us as we go on. Takeaway 2 from this whole thing was that you can't waste time by learning. And learn I did. NumPy, if you haven't heard of it, was one of the stars of this project. It's an accessible way to do matrix operations, and it does them blazingly fast. I spent a lot of time messing around with it so that I could do the things that I wanted to correctly. But it has a lot of features that are beyond my interest level. It's much easier to pick a particular problem and solve it the way you'd like. Like here, can we solve those outer 2 for loops into one? And the answer is yes. As a vectorized language, NumPy can check every spot at once to see whether it's less than or equal to the level, and then just iterate through the relevant squares. Of course, we're not satisfied there. We're going to start looking at that next thing, where for every neighbor in the resulting spot, we want to do a bit of math. And the thing about that, to me, is it sounds like numerical convolution. And for those who are unaware, numerical convolution is a process that shows up a lot in both image manipulation, machine learning, anywhere that big data shows up and needs to be condensed. The advantage to it showing up in those places is that some very smart people have worked very hard to make these libraries blazing fast. The scikit-learn library was another hero here. And as a very, very quick overview, in numerical convolution, you take a moving window called a kernel, here the thing of ones around a central 0, and you multiply that by the grid values at each location. Then you sum them up and put them that corresponding location in a new grid. And since it'll do what we want, but not directly, we have to be clever here. So the first step in revising this function is we do that vectorized comparison. It'll get us all of the neighbor values that we're interested in, here highlighted in green on the right. From there, we take a kernel that only looks at those neighboring values, and it convolves them. And it'll get us an array like the one on the right, where all of the values in blue have a positive value. From there, we can use NumPy's AND function to try summing the two together. And wherever it's above 0, it's safe to click. And altogether, it can be reduced to 4 lines of code, where we get the neighbors quickly, we generate a kernel, convolve it, check if it's above 0, again, a NumPy thing, and then use a NumPy alt, check if it's safe to click. Unfortunately, we are not going to be able to do that live demo again, but that's why I have a safety video. And from here, it actually is a little bit more intelligent. You'll see that it starts at the edges, gradually works its way inward. And even if it does make a small mistake, it's generally low enough pressure that it can succeed. However, it isn't perfect. If you try with that strategy on a more sophisticated difficulty, you're only one step up to normal. Come on. Now, can I get a safety video for my safety video? Screen. Nope, no time. The safety video is also laughing at me today. The problem is it will fail at that, as it just simply does not have enough information. And getting there was really thrilling. It does work, it's vindicating, but was the optimization worth it? The answer is, well, maybe. It's a very I/O blocking process. The automated clicking and automated screenshots take a lot of time. And relative to that, calculating the strategies only takes about 3% of the total volume. So was it worthwhile? I'm here to argue, yes, of course. One of my big takeaways was that learning during personal projects helps you complete them for 2 big reasons. Here, the later strategies involved much more challenging uses of NumPy and even more challenging uses of convolution. That convolution step later on, I even used to determine the direction of certain unclicked tiles in a move that is either very smart or very stupid. I'll give a link to my GitHub at the end and you can determine which you like. And in schools, it's only taught as a way to blur or sharpen images, which is significantly less interesting to me. But more than that, learning is worthwhile. This is just-in-time learning. If you're into educational sciences, the most powerful way of doing it. Of course, we aren't here just to learn. We have a goal in mind. And that was the third takeaway about how I got a personal project completed. Having a goal gives you something that, even if things are going well, keeps you going through to the end. And my goal was very simple: victory over all of the people on speedrun.com. It lists the top times of many video games, and Mammono Sweeper is no exception. I wanted my script to get first place in every category, even the hard ones. In the interest of time, I'll skip other strategies and jump straight to the times. For humans, it ranges anywhere from 19 seconds for easy mode up to 13 minutes for huge and extreme. So let's see what the final product looks like. Oh, thank God. This safety video works at least. So it's, again, doing something that I would do, only very quickly. It starts at one edge, gradually moves over, eliminating that complexity and uncertainty I was talking about to get to the point where it can finally click later. Has some other behaviors which I would love to talk about outside of this talk. And yeah, it gets it done with the in-game timer at 21 seconds compared to the human 13 minutes. Thank you. talk to me after this. I will show it to you whenever I can figure out whatever's going wrong here. From there, what else? We got all of the times down. Whoop, where are we at? Yeah, we got all of the times down. The huge and extreme was the 1 above 20 seconds. But it's not perfect. The blind modes in particular don't offer a lot of information to the player and take a lot of guessing. I'd love to go back and work to increase the success rate, either using neural networks or statistics. The advantage of using a neural network is getting training data is really easy. It shows you where all of the monsters are if you fail, and you can always just randomly make new boards for yourself. Of course, this is well out of my wheelhouse, so much to the point where I don't even know how to break down that project into manageable chunks. Meanwhile, statistics are guaranteed to work. Some configurations of monsters are less likely given the info, and if you compute all of those configurations, you can find the mathematically safest square. And even better, there's existing problems that look a lot like this, either the partitioning problem or constraint satisfaction. And if you know anything about those, you know that that's also a problem. That's right, those are NP hard. Therefore, Minesweeper is NP hard, or NP complete at least. And if it's on an infinite grid, you can make logic gates, meaning that infinite Minesweeper is Turing complete. So making a solver for this that functions quickly would make me wildly famous, and I would probably talk about that instead of the video game script. It does also mean that you could make a version of Minesweeper that you play by playing a version of Minesweeper. Kind of weird to consider. But beyond these challenges, I'm still tempted to try. In real life, NP hardness is a classification of a problem, not a measure of how difficult it is. A hack-together statistical solver might just work. But I still don't feel too bad stalling out here. If you take anything away from this, if you're running into difficulty coming up with personal projects and actually getting them done, I really felt that these small, easily taken steps made this project get done. At every time, I could rephrase it to be just a little bit outside my comfort zone. Also, whenever I needed to learn something, doing so by optimization was fun and natural. And of course, having that goal in mind kept me going even during tough parts of this project. On a more practical note, for the hackers in the audience, the loop of using MSS for screenshots, OpenCV to parse them, and then using PyAutoGUI to click on them is incredibly powerful. Basically, it reproduces anything you or I do at a computer. The code's very approachable, and I'll have a link to my GitHub at the end. And this would be a natural place to stop the presentation, but something about it left me feeling a little creeped out. Part of it was that I finished this project. I took the videos of my fast times, did the final push-up to my GitHub on November 16th, 2022. And 2 weeks later, to the day, ChatGPT was released to the general public. And suddenly this cute tool for automation got a little bit strange. See, the whole look at the screen, think a little bit, and then click loop was a lot more comforting when it was complicated to do high-level things in that think step. And suddenly that simple to set up and execute, simple to set up a thing that looks human got a little stranger. I'm not a complete idealist. I know that there's some bad you could do with this, or at least neutral. Take, for instance, Twitter's decision to shut down their free API tier. Well, this is a big blow against botnets and personal projects and art installations and citizen science. It's undeniable that it's going to get in the way for a lot of programmers. However, a loop like this cannot be stopped. No matter what Twitter does, as long as they are still Twitter, they'll let the average user post from their homepage. And of course, you might be thinking, well, there's ways around this. What about CAPTCHAs? To which I ask, what about CAPTCHAs? In addition to the security researchers always testing whether AIs can beat them, there are human services designed to beat them for you and send you the results back. This one was not hard to find, even though I tried my best to censor the name. And of course, one other option that I found 2 weeks before my last presentation was you can completely redesign things. That's right, a decade and a half old video game got a visual overhaul, which ruined the MSS finding the landmarks, changed the grid widths, and somehow it no longer registered clicks from PyAuto GUI. And I was panicking. Of course, this was before PyCon Taiwan, trying to make the script work. But ultimately, I didn't need to. The dev wound up releasing the old versions because of player pushback on Twitter, not even from me. So it might not be the best option if you have something you want to block people from. Ultimately, I am of the opinion that as devs, we should try our best to automate stuff. That's why I came here and why I'm so excited to talk to you all. I hope you're inspired to try and automate things, maybe even your entire job. Tell me, that'd be really cool. But of course, we should also do sensible human checks where appropriate. CAPTCHAs if it's inconvenient, maybe phone number. And of course, if we have an API to blow up the world, maybe it doesn't matter if it's a computer or a human hitting that API. We should limit bad actors regardless. Of course, as people, I think it's the best chance to limit what automation can do negatively. If we're kind, if we make strong communities where harassment and misinformation is not tolerated, it doesn't matter whether it's automated or human-based. It'll stand out, and we can stop it there. With that, I would like to say thank you so much to everyone, especially my coworkers who flew 30 hours to get here. Thank you to the organizers, the folks in the booth, and of course, to all of you for your attention. Thank you for your time. Do we have any time for questions? Perfect. This is also the slide of all of the information. The content here is written up as a couple of blog posts as well, if you'd rather read about this later.
Questions up for asking for more info from the speaker. If you have your own you would like to share, please submit to the CFP next year, just as a reminder. Yeah?
Did you ever upload your results?
They're on YouTube. But unfortunately, speedrun.com has human categories and tool-assisted categories, and there wasn't a tool-assisted one for this. But I would be at number 1 and only. Thank you so much.
Do we have any more questions?
Yeah.
I want to know what would be your next game that you would want to automate?
I was actually thinking about this. Someone asked it last time. I'd love to go back and actually try to hack together a neural network on this. But if I had to pick a new game, they have like idle games where you engage every so often. And one of the ways that they keep you engaged is you have to control rates of things depending on what you buy. And Python can do rates. That's just simple calculus. And I would love to see what the theoretical max would be with those. Thank you so much. And if you find a game, please give it a shot. I'd love to hear about it.
We have time for maybe 1 or 2 more, if anybody else has a question. Oh, there we go.
You mentioned you used OpenCV. What other cool functions in OpenCV did you come across other than just, screen capturing the, the screen?
Oh, fantastic question. So the reason I picked OpenCV is I used it in another personal project. A friend of mine made a webcomic, and I noticed that the colors changed pretty distinctly from chapter to chapter. OpenCV has something called k-means clustering, which lets you condense an image into just a few colors, either for compression or, in my case, curiosity. So I wound up making this image of here are the colors of each panel of each page, and you can kind of see the arc of the story. It's really cool. K-means clustering is mostly used in machine learning now, but also for art. Thank you.